Sir, I have a small doubt. So this
Padmasri, if
data.
wait, Karthik. Padmasri, if you are not able to listen, rejoin the speakers. Everyone is able to listen, right? Vishwanath, Vasant, Prabhalika,
Yes.
Jasmita. Yeah, Karthik, you can go ahead.
Sir, this data cleaning means converting object into integers, sir.
Not only that one. So null values filling. So we did some grouping, right? So we need to do some analytics, all those things. So converting object into numerical format, numericals into string format. So converting, if it is datetime column, we need to convert into pandas datetime format. That is also part of the data cleaning.
Okay, so that means changing object to some another.
Not only that particular thing, that is only one of the minor step in the data cleaning.
Okay.
That is one of the steps. That is not the specific one. So there will be multiple steps. Like I told you, if normally if the data is numerical, sometimes whenever we read from the pandas data frame, it could have saved in the format of object. But in reality, that column is numerical. Then we need to convert that into numerical. That is one of the steps in data cleaning process.
Okay. That's it.
Okay. So, anyone? As of now, we are able to discuss. So we are able to complete Python. We are able to complete statistics. We are able to complete so clustering project and the clustering definition. What is unsupervised learning? We have discussed. And when it comes to the supervised learning, we do have two things. We have two techniques. We do have. So one technique is regression. Another technique is classification. That is what I have mentioned here. So regression, some problem statements will come under regression and some problem statements will come under classification. So now we are going to deal with regression. So tell anyone what is regression and what is classification. Just a moment, within 30 seconds. Anyone can take it.
If we are trying to predict continuous value, it is called regression.
Okay. So what about classification?
Classification, we do have categorical values.
Okay. Can you give any one example for regression and one example for classification?
Like continuous values, like the stock exchange, like it should be in
Stock
price.
prices. Okay. Yes. Stock prices. Next.
Classification, like Amazon.
No.
Like
regression gives some more examples. Either one or two.
Sales predictions.
Exactly.
And bike price increase, decrease.
Exactly.
Coming to classification, like customer review, like product good or bad.
Okay.
And Amazon customer reviews, like the particular product. Those kind of stuff.
Okay. Next.
And the rating, like in terms of
the same thing will come under the same rating and this bad or good, positive or negative, some other type, some other scenario.
like binary classification.
Marks prediction.
Yeah, Padmasri.
Students' marks prediction.
Student marks means what is the marks here?
No, it's he's failed or passed, like that.
Exactly. See, if you are predicting student marks, that will come under regression. If you are predicting whether the student will pass or not, that will come under the classification. And next, for example, you can go to any insurance sector. Like predicting insurance premium for any one of the customer. So predicting premium is value like 15,000, 30,000, 50,000, 1 lakh. And next, the same insurance sector, whether the customer will take insurance or not. That is, so the same thing, it is insurance sector. When it goes to the agriculture sector, so you can take any problem statement in agriculture sector, like whether the crop is having any issue. So what is the disease the specific crop is having? When it comes to the healthcare, so whether the patient is having cancer or not, whether the patient is having some other disease, not only cancer, whether it could be any dengue fever, something else, whatever it is. So if you are predicting yes or no, it could be yes or no, or it could be more than 2 also. So if it is 2, we will be calling that as binary classification. If you are predicting more than 2, that will be called as multi-class classification. So if you see in the cancer also, we do have multiple types like lung cancer and blood cancer and bone cancer. If you are predicting 2 things like bone cancer and lung cancer, that is binary classification. If you are predicting more than 2, that is lung cancer, bone cancer and blood cancer. These 3 types. It could be anything. It could be 20, 30, 40, 50, any number of classes. This will come under multi-class classification. So before going to there, can anyone tell me what are the algorithms are there in regression problem statement? We have already discussed these algorithms also. I have typed each and every algorithm name and I have provided the Excel sheet also.
Here regression, KNN.
Okay.
Decision tree, random forest, XGBoost.
Okay.
XGBoost
Apart from
regression
that,
and classification both are there.
okay, can you tell from the starting again?
Linear regression,
Okay.
KNN regression.
What is
support vector
KNN?
regression.
KNN full name? Okay, that's fine.
Nearest neighbor.
K nearest neighbors. Exactly. Yeah.
And support vector regression.
Okay.
Decision tree.
Decision tree regressor.
Decision tree regression, random forest regression, XGBoost regression.
Okay, it's not regression. The algorithm name is regressor. So linear regression, regression will come for linear regression, and for remaining KNN regressor, decision tree regressor, random forest regressor, like that. So can you tell from the classification perspective the algorithm names?
Yeah, logistic regression algorithm.
Okay.
KNN classifier algorithm.
Okay.
And decision tree classifier.
Yeah, exactly.
And random forest classifier.
Exactly.
And XGBoost classifier.
Okay, perfect. So that is enough. See, whatever the algorithm names, you remember, that is fine. That is not the algorithm. So now we are going to discuss about the first and important and basic algorithm, linear regression. If you are learning this linear regression, then it is easy for you to understand the logistic regression. So here, within one thing, with the same formula, we will be understanding what is linear regression and what is logistic regression also. So let us see, before going to the regression algorithm and before going to any other algorithm, let us see the pipeline. So what is the project flow? What are the steps we are going to cover in any project? Whether it's regression project, whether it's classification project, whether it's clustering project, everywhere the project flow is same only. Okay, first what we need to do, we need to import the necessary libraries, whatever we need for that project. Maybe in between you will be getting lot of libraries, you will be using lot of things. There is no need. First, whatever you remember, whatever you thought of you're applying in your project. Anyway, pandas you will be applying, numpy you will be applying, and Seban you will be applying, and scikit-learn you will be applying. Those things you will be adding at the first. So remaining whatever comes in between, you can add it later also. So these are just definitions. So machine learning is just like, this is the basic algorithms which we are going to discuss right now. And next, deep learning is like advanced algorithms for this machine learning. Whatever the things we are discussing in machine learning, so it will work some level. But when it comes to the deep learning, these deep learning algorithms will work effectively as compared to these machine learning algorithms. So now let's move on to the ML pipeline. So machine learning pipeline. So for any data science project, any machine learning project, any deep learning project, whatever it is. So artificial intelligence is nothing but just like advanced form. It's like adding human intelligence, like we will be seeing in the robots, all those things, right? That is very high level subject. For the time being, in the industry, we are going behind till this deep learning only. And apart from recently, we have added, the industry got completely improved with the large language models. That is also we are going to discuss as part of our course curriculum. So large language models and pre-trained models. These things also we are going to discuss. Okay. So next, when it comes to any project, I have already discussed it, whether it's regression, classification, or clustering. We need to understand the problem statement. That is defining the objective. Defining objective means understanding problem statement. Understanding problem statement or understanding use case. Don't confuse with that terminologies. Normally, this use case word will be used by the higher level management. So one problem statement is like one use case for higher management. So normally, whoever the people like CTOs, CEOs, they will be using this terminology. We need to understand the problem statement. So let us suppose we will be taking a problem statement. We want to predict the sales price or stock price or insurance premium, whatever it is. It could be multiple. This problem statement we need to understand first of all. So after understanding the problem statement, so here domain means the problem statements, the use cases will change from domain to domain. So domain means retail domain. So e-commerce domain, insurance domain, automotive, like automobiles. So agriculture, extra, lot of things are there. So retail, e-commerce, insurance, automotive, agriculture, and network. That means telecommunication. Telecommunication like Vodafone, Idea, Geo, all these things will come under. So if you are going to work on any retail companies like DMart, More, that will come under the retail domain. If you are going to work under some e-commerce websites like Amazon, Flipkart, some other websites are there, e-commerce, online. So that will come under the e-commerce domain. Next, as usual, insurance, everyone knows. So we will be taking policies, LICs, and some other HDFC insurance. All will come under this insurance. Next, automotive. So like Bench, Volvo, so whatever the car companies or bike companies, Bajaj, something else, all of them will come under this automotive industry. And next, when it comes to the agriculture, some agriculture companies are there. They will be focusing on pesticides. They will be focusing on crops issues. They will be focusing on so what is the disease the crop got it. And next, telecommunication. Telecommunication like mobile networks or Wi-Fi, ACT. We will be using ACT, Airtel, all those things, right? Everything will come under the telecommunication. And next, healthcare, especially. Why? Because nowadays, so majority of the development happening in healthcare. So, like predicting cancer-related things, predicting any issues, predicting any flu. So, like COVID, all those things we are going to predict. We can predict by using this ML models itself. So these are all the multiple domains. You may get opportunity in any one of the domain.
Excuse me. Any
Yeah.
manufacturing?
Automotive is manufacturing.
Okay.
Yeah, manufacturing also that is another thing. So manufacturing will be covered everywhere. See, in the automotive, manufacturing will be there, and in healthcare, some vaccine-related products, some other medicines manufacturing, drugs manufacturing, everything will come under the manufacturing. No issues. But that manufacturing also will be having its main domain, right? That manufacturing, either it could be healthcare, either it could be automotive, something else. But this insurance, e-commerce, here we don't be having manufacturing. But in the retail also, you will be getting some manufacturers, products related manufacturers, all those things. Okay. So once the problem statement is understood, the next step is we need to go behind the data related to that use case. So for example, I want to predict insurance premium, let us suppose, or else I want to predict whether the customer is satisfied or not. So and next I want to predict so how much sales my company like DMart, how much sales the company generate. So how much sales my product will be sold. So like in the telecommunication also. So whether the customer will leave the company or not. So whether the, and I forgot to mention another thing, yes, banking domain. So banking is also another domain. So like whenever we are using our credit cards, our net banking, in some scenarios we will be getting transactions declined messages. So it's like they will be sending some messages like there may be discrepancy in the transaction. So the transaction is not eligible. Like that we will be getting. That means the algorithms backend, it was able to identify some fraud transaction happened. And in some scenarios, you may be getting calls from the telecallers like, sir, whatever the transaction you have done, just confirm me whether this transaction is you only did or some other else to prevent that fraud. Actually, whenever, for example, if I did transaction around 80,000, 1 lakh, sometimes immediately I will get call from the telecalling team. Sir, you did 80,000 transaction. Is it true or some other else did? So whenever I did that 80,000 transaction, that was predicted by the machine learning model. So this is like a fraud transaction. Then immediately the message will be passed over to the front end team, and the front end team will call the customer, and they will be informing the customer. So if the customer says, okay, I only did this, then they will say, okay, sir, we will continue with the transaction. Like that. Some scenarios, they will be holding the transactions also. Like that. So for example, if a person is having credit card with 5 lakhs of 5 lakhs of amount in this credit card, if the customer is not using that credit card for a long time, he may, for some reason, he may use that credit card for 2 to 3 lakhs. Then immediately it will trigger like it is a fraud transaction. Why? Because for the past 4 to 5 months, he didn't do any transaction, but somehow he did 2 lakhs transaction. My model will understand, okay, this user didn't do transaction for a long time. He did it now. There may be a chance of fraud happening with this credit card. Then they will take some steps and they will call the customer and they will try to reduce the fraud. Like this, lot of applications are developing. By using this machine learning. So nowadays, each and every application is moving behind the machine learning. So that's why the requirement of data scientists are increasing day by day. Maybe they would have developed the application 3 years, 5 years before, And recently they started developing, applying machine learning concepts to the data sets, to their things, all those things. So for this, we need to have the domain knowledge. So whenever you are attending for the interviews, maybe if you are having any experience, we can make, based on your experience, we can prepare the resume. If you have worked in retail domain, if you have worked in e-commerce domain, if you have worked in automotive domain, we can frame our problem statements based on that specific domain. So the next important thing is data collection. So each and everything will have some weightage. Without understanding the problem statement, we can't go behind the data collection. Data collection also most important. So you need to collect the data from the different sources, and you should be in the situation to identify the correct data also. So before going to the data collection, you need to connect with the domain experts, you need to connect with your client, you need to connect with your manager, everyone. So somewhere they will be having a dump of data. In some scenarios, some projects, you may not get the data also. At that time, we need to do research, we need to search for research papers, we need to take some open source data. So that by utilizing that open source data, we can add it to our own data set and we can build our machine learning models. So this is the thing. So data collection. This is also most important. The client may be maintaining the data in multiple sources. Like one source of data he may saved in Oracle database, some source of data he may saved in MS SQL Server. So some source of data he may saved in MongoDB. So there are multiple databases out there. So there is no need to learn about all the databases. Just if you are able to learn connecting to the database and extracting the data, the same methodology we can apply for other databases also. And next, once data is collected, we need to prepare the data. Preparing the data means we need to clean up the data, we need to rearrange the data, we need to arrange the data, we need to manipulate the data like so all this cleaning like so whatever so object values, string values, float values, we need to check each and every column. So we need to drop some of the columns. We need to check some correlation techniques to drop some of the columns. We may be filling the null values or dropping the columns with null values, all those things. So you will be spending 10% of your time on this objective definition, that is understanding the problem statement, and some 15% of your time you will be spending on this data collection. And next, preparing the data. Completely 40 and 50% of your time you will be spending on this data preparation only. Preparing the data means data pre-processing, data cleaning, data manipulating, everything will come under this data preparation only. End of the day, model building, you will be spending only 10 to 15% of your time. So for example, you have 6 months allocated for one project. So within this 6 months, you will be spending 2 weeks, let us suppose. 1 or 2 weeks. 1 or 2 weeks, use case understanding. Next, data collection. It is also 1 or 2 weeks. If the data is available, it will take within 1 week. If the data is not available, we need to search for resources, and we need to buy. In some scenarios, we need to buy the data also. So next, so here data collection completed, data preparation. That means data pre-processing, data cleaning. Here it will take 2 to 3 months. Literally, it will occupy a lot of your time. Whatever the time you are saving here in use case understanding, whatever the time you are saving in data collection, you will be utilizing that time in this data pre-processing, data cleaning. So next, So here also, model building also, it won't take more than 2 weeks. Model building. So how many months it's over? So let us suppose here it is 3 months, here it is 1 month, here it is 3.5 months. So last 1 month to 1.5 month model testing and model manipulating, model improvements, manipulating means. The next, production code development. All these things we will be doing at the ending. Why? Because we need to monitor our model. So till whenever this data preparation is ready, then we will be dividing our data into training, testing, and validation. Some scenarios you may be considering this validation, and sometimes you may not need to consider this validation also. Normally, in the machine learning algorithms, we will be taking training and testing. When it comes to the deep learning, we will be putting some 10% of data for validation also. So let us confine till machine learning only. So here what I did, if I have 100 rows of data, I will be training my data on 80 rows and I will be testing on 20 rows. So what is the use of taking 20 rows as testing? Why? Because whenever I train my model, let us take our classes as a reference. If I am explaining any concepts to you, so how will I know whether you understood or not? So if I ask any question, if you are answered, then only I can understand you guys are understood. If you don't give any answer, if you give wrong answer, that means you didn't train well. The same thing happening with ML models also. We are telling to the ML model, if you are getting this type of data, predict this much sales, predict this much premium, predict this much, so whatever it is. What I'm doing, 80% of my data I will be training and 20% I am making it separate and predicting on that, and I will be comparing the results. Why? Because the 20% already I do have some sales value and some insurance values, some premium values already available. So my model predicted values and the actual values I will be checking, and I will be checking the error over there. So how much perfectly my model is working. That is how the accuracy of ML model came into picture. So this is the complete life cycle of ML project. So when it comes to the validation set, we'll discuss this validation set. So here we do have one concept called k-fold cross validation. In this, normally 1 to 20 rows is one box, 21 to 40 rows is another box, 41 to 60 is another box, 61 to 80 is another box. So this is my training data till 80 rows. We have already discussed. For training data. Next, test data. So in the test data, 81 to 100%. Either it could be random or it could be like in this manner also, it is fine. In the k-fold cross validation, whenever we are training our ML model, so we will be taking these 3 boxes as training data and we will be testing our ML model on this validation data. Like this is in the first phase. That is what I have mentioned here. So in the 5-fold cross validation, we will be dividing our data into 5 folds. This is 1 fold. This is 2nd fold. This is 3 fold. This is 4 fold. Here I took only 4 folds. Here k value is 4. If I am taking 5 folds, that is 81 to 100 rows. This is 5-fold. And here in the test data, it will come from 101 to 120. In the k-fold cross validation, it will take first 4 rows will go for training and the last box will go for validation. So it will train on this data and it will validate on this data, and again the model will rectify its error if we do this k-fold cross validation. So this is in the first phase. It will take these 4 and it will validate on this thing. In the second phase, it will take remaining 4 and it will validate on this one. In the third fold, it will take this one as validation and remaining as training. So like this, if you are using 5 folds, it will do 5 iterations. That means the model will run on 4 chunks like this. I have mentioned here, right? So 1, 2, 3, 4 into train data and 5th into validation data. In the second iteration, 2, 3, 4, 5 into training data and first into validation data. Like this, it will do 5 iterations. For example, if you are using 10 folds, it will do 10 iterations. The model will train perfectly if we use this cross-validation techniques. So once everything is ready, we need to split our data. That is what we have discussed till now. And next, selecting the algorithms. So till now, you are able to divide what is your input column, what is your target column, that is output column. You need to select the appropriate algorithm. If your target feature is regression, you need to select regression algorithm. If your target feature is classification, you need to select classification algorithms. So you can't mix it both. If you are working on class labels, you can't use regression algorithm. If you are working on regression, you can't apply classification algorithms. It won't work. So if you are working on clustering, you need to apply clustering algorithm only. That is all. So within this algorithms also, you need to select the best algorithms. We do have multiple algorithms like linear regression, KNN regressor, support vector regressor, Bayesian regressor, random Bayes regressor, and after that XGBoost regressor. If we go higher level, we will be getting some other deep learning algorithms like ANN regressor, like artificial neural networks regressors. Next, CNN regressor, so that is convolution neural networks. In the convolution neural networks, we do have different things. And in LSTM regressor, so that is a long short-term memory, that is deep learning. We will discuss all those things when it comes to deep learning. Okay, the best algorithm we need to select. To select that best algorithm, which algorithm is giving the good accuracy, which algorithm is working faster, we need to select that algorithm. Next, to select which algorithm is working fine, we will be using this evaluation matrix. We will be using this evaluation matrix. Like accuracy, I will be telling, right? Accuracy. In the same way, for regression, the evaluation metrics are different. For classification, the evaluation metrics are different. You need to remember both of them. See, whatever the theory I am telling, it should be in your mind continuously. You should be in the situation to explain each and everything clearly. It's like step-by-step process. So once we check the accuracy, if the model is performing well, then we will be doing the predictions. So how we will be doing predictions? So we need to pass new data set, then the model will do predictions. So next, algorithm, what are the, when are dealing with projects, what are the blocks you will be getting? What are the challenges you will be getting? What are the issues you will be getting? So first of all, the first issue is understanding the problem. Sometimes you may not get clear problem statements from the client. You may not get clear use case from the client. So for that, you need to understand the problem statement clearly. And next, you need to analyze the data. You will be facing a lot of issues in analyzation, writing the Python code and preparing the data. So some scenarios, you may get data in the format of PDF files. Right? If you get data in the PDF files, it will be difficult for you to process that PDF files. You need to structureize that. The PDF files is completely unstructured data. So you need to structure it. So at the time, you need to face some difficulties and you need to face some challenges. And next, selecting the best algorithm, like the model should give within less time, the model should give correct predictions. All those things you need to focus, and you should improve the results. So you should improve the accuracy. All those things you need to focus. So in the machine learning types, when it comes to the machine learning types, these are all the multiple things. Supervised learning, unsupervised learning, we have already discussed. Semi-supervised learning. So semi-supervised learning means only some rows of data will be having target feature and some rows is having null values in the target feature. So in that scenario, we need to fill in those null values in the target feature. So normally in the input feature, you may get null values, but in the target feature, if you get null values, how can you deal that? You need to deal that. You should be in the situation to deal those null values in the target feature also. For that, you should have domain knowledge, and if you don't have domain knowledge, the companies will be having domain experts. You can connect with them, and you can fix the issues. And reinforcement learning. So reinforcement learning is nothing but just like we will be using in this robotics, robots, all those things. These concepts are used. So this is not that much important. So till here, it is important. Semi-supervised is nothing but target feature is not fulfilled completely. That is the only issue. So next, simple examples. We have already discussed all these things. So these are all the steps I have mentioned. So unsupervised learning, we have mentioned. So semi-supervised learning, so reinforcement learning, all these things I have given. So these don't worry about this reinforcement. Why? Because you can't learn everything. You can't learn everything. You can't become anything. You can't learn everything that much easy. So this is the project flow till now. So let us see what is regression and what are the evaluation metrics for regression and how many types are there in linear regression.
Nagendra, I have two doubts.
Yeah, please.
If suppose while coming to data collection, we don't have any data sources like any databases not provided by the customer or client. So at the time we can collect the data from the open source.
Yes.
So that open source data is common for, if we consider any kind of retailing. So that open source data, that header is common for all types of retailing projects, or we can search what are the main headers we are using mostly in all retailing projects like that.
Yeah.
That's the
See, if you are taking open source means the data is open for everyone. Let us suppose we are trying to build. Yeah.
But we don't want to build our model. We not required all the columns, right?
You can drop whatever the columns not needed for you.
Okay.
That is the data pre-processing you are doing now.
Yes, yes.
See, you went with open source. In the open source, you got 100 columns. You don't need to build your model with 100 columns. You can build your ML model with 5 columns or 10 columns. You can drop unnecessary columns by applying some of the pre-processing techniques like correlation is one of the technique which you can use to remove some of the correlated features. And apart from that, in the linear regression or logistic regression or decision tree or random forest, you will get importance of each and every input column also. For example, if you have 100 columns, that importance, this feature 1 is higher level, feature 2 second important, feature 5 third important. In there, you can select top 10 features that will come under our projects. Okay, you can build anything. So let us suppose, let's take one example with your doubt. I want to build a sentiment analytics tool. So normally in the industry, sentiment analysis is nothing but just whether the customer is satisfied or not. So whether customer is giving positive review or not. So normally why the companies are taking this sentiment analytics tools is like, so just to know about their customers, how much they are satisfied. So if they are not satisfied, they will try to satisfy the customer. That is how they will do. Either the review they will be taking either in the format of telephone or they will be taking review in the format of text also. In some scenarios, you may get reviews in the sarcastic nature also. Okay, hope you guys know what is sarcastic. Sarcastic is nothing but just like so we will be giving some in the different manner. So either it could be positive or it could be negative. It's like satirical. So when it comes to the sarcastic, it could be satirical. Normally, sarcastic is examples. If you read in one example, so that whenever we are going to collect data from the customers, we won't get these sarcastic messages sometimes. So for that, I will be going through some of the sarcastic messages from the open source. So already Twitter is maintaining some of the sarcastic messages, and some other websites also holding some of the sarcastic messages dump. If you see, read the message here, ordered a pizza and delivered half a pizza to me. Rang up to be told I need to pay for another pizza. Joke of a shop, avoid. So here the bot reply is, normally this is ML model Reddit, and it is able to tell, hi Jenny, hope you are doing well as you have ordered a portion which folded posa it's come like this. Normally here the customer is not satisfied in this review. By reading this manually we will get to know, but here machine is not able to understand. Machine understood this as positive review. That's why it is telling like this. So if I am able to predict this message as sarcastic, then my model will tell, okay, he is sending some sarcastic messages. That means the customer is not satisfied. Let us take his feedback like this. See, food come freezing cold and was an hour and half wait for a wrap and chips. He is completely dissatisfied. But the review which he has written is, it's completely the sarcastic nature, in the satirical nature. So we need to collect our data in the sarcastic nature also. For this, we need to go with the open source data set. If we have sarcastic data, then we can utilize it. But what if I don't have this sarcastic data? I can take open source, and this open source data, I can add it to my data set and I can apply it on top of it. Clear?
Yes, yes, clear.
Yeah.
And one more doubt regarding
Yeah.
to this data cleaning and all.
Yeah.
If suppose we are getting some mismatched data, or in place of dot, suppose we have example like insurance, no? So in that we have amount, billing amount like that.
Yeah.
In that dot will place after 3 digits. Then at that time,
We need to clean up. We need to clean up. That is what cleaning will come into picture. So whatever the question is, let me
If-
frame that.
maybe in place of dot we will get any kind of comma.
You may be getting dollars, you may be getting
Yeah.
anything. You need to
That's
remove. That is a cleaning process. Say
Because
whatever your doubt
it will
is.
come in suppose PDF file.
Yes, it will come. It will come.
If
We need to
Excel
do.
means okay, okay, then if it will be coming PDF file means
See, PDF file means we do have some libraries to extract the data from PDF files, and we need to prepare the data like this in this tabular format wherever it is. So for example, here you got sales value. So normally whenever they will be saving $1,000, so $2,000, so $3,500. So in this scenario, you don't need this dollar letter in your model. What you need to do, you need to clean up this. You need to clean up this. That is mandatory. You need to clean. So without dollar. So you will be using some of the techniques to remove this dollars, all those things. This is where the data cleanup came into picture. So what if you have multiple columns like this? So in one column, you do have dot. So in another column, you do have underscore. You do have dot in between. So 1,000.
if suppose in one column only few of the rows with the dot, a few of the rows with the commas, like that.
Yes. If you apply the, yes. If we will be having some patterns if you apply that pattern, some of the wherever it is find this dollar, it will remove that dollar. Wherever it is not finding, it will be leaving. No issue in that. See, we do have concept.
We can easily identify, find and replace. We can change that
Yes,
dollar
yes.
into.
Yes, yes, yes. You can use the replace methodology, or you can use the split methodology, or we do have some other concepts called regex patterns. By using those regex patterns also,
Regex
you can
also,
remove.
yes.
Yes. It's all part of the data cleaning. That's why in the project flow, I have mentioned 2.5 months for that data pre-processing itself. That means all of the cleaning you should do. So each and every column should be clean and clear, like that.
Excel files, CSV files is fine, but I'm thinking about PDF.
Yes, yes. You will be getting a lot of issues. See, whatever the data we are explaining to you now, so there are a lot of changes. You will be getting real-time data sets. So only very 30 to 40% of your time you will be getting clean data. Remaining 50 to 60% of the time you will be getting some clumsy data we need to clear it. That's why we are spending that much time on our cleanup online. Clear? Yeah. So in the regression, we do have two types. So one is linear models and another one is non-linear models. So when it comes to the linear models, linear regression is the linear model. So apart from linear regression, remaining everything else non-linear models only. So in the linear regression also, again, we do have multiple types. So simple linear regression is one type, multiple linear regression is another type, polynomial regression is another type. So these three are related to linear regression only. Apart from these three, again, two more algorithms are there. One is ridge regularization and lasso regularization. These two also related to linear regression. Why? Because the same formula we will be using in all these algorithms. Simple linear regression, multiple linear regression, polynomial regression. Apart from this, decision tree regression will follow its own structure. Random forest will its structure, and support vector regressor also will follow the same formula whichever we are using in the linear regression. So let us move on to the linear regression. What are the types in the linear regression one by one? So in the linear models, we do have linear regression. So again, in the linear regression, we do have simple linear regression, and next multiple linear regression, next polynomial linear regression, next ridge regression, lasso. So all these are linear models only. All are related to this simple linear regression only. And next, non-linear models. Except these things remaining are non-linear models only. So whatever we do have below, decision trees, random forest, support vector, KNN, all these things will come under the non-linear regression only. And one more thing, elasticity regularization. So this is also part of this regularization only. So this regression types are. So this regularization is nothing but we are trying to improve our linear regression algorithms, nothing more than that. So let us see one by one. what is simple linear regression, what is multiple linear regression, what is polynomial regression, what is ridge regression, what is lasso regression, and what is elasticity regression. We will see one by one. So before going to the algorithms, let us see, we have discussed this performance metrics. Model accuracy check we have mentioned, right? That is performance metrics. Yeah. So evaluation metrics are performance metrics. For regression, the performance metrics are different, and for classification, the performance metrics are different. So let us see what are the performance metrics are there for regression. So first performance metric is MAE, that is mean absolute error. And here the MAE value should be near to 0. If your value near to 0, that means your model is performing very well. And next, MSE, mean square error. So value must be here, it is also near to 0. And next, RMSE, root mean square error. So it is also should be near to 0. And next, in the real time, you won't get 0 value, but it should be nearby. And next, R square. So R square is nothing but just like calculating the accuracy. So here value must be near to 1. See that difference. So R square, the value ranges from 0 to 1. So if it is nearby 1, it is working, the model is working fine. For example, if you are getting 0.9, 0.95, 0.98 like that, it is working fine. Next, adjusted R square. Adjusted R square, it is just advanced form of this R square. The same formula, little bit modification, adjusted R square came into picture. So here value must be near to 1. It is also value must be near to 1. So let us see the formula for mean square error, mean absolute error, all those things. We will apply this mean square error, mean absolute error, all those things whenever we are going to discuss in the project, let us see. So these are all the theoretical concepts you need to remember and you need to by heart. There is no other option. Whenever the interviewer asking you what are the performance metrics we can use for regression, you need to tell all these performance metrics 1, 2, 3, 4, 5. Whenever the interviewer asking what are the performance metrics for classification, you need to tell confusion matrix, classification report, accuracy, precision, recall. Those things we will discuss whenever we are going to discuss about classification. So this is regression models introduction. Now let us see what is simple linear regression, what is multiple linear regression, and what is polynomial regression. So simple linear regression is nothing but simply you will be having only one input column, one output column. Now tell me one answer. So how many input columns could be in any model? So is there any limit for input columns? The answer is there is no limit. So the input columns could be any number. It could be 5, it could be 10, 15, 20, 30, 100, 150, 200, whatever it is, based on the requirement. But if you have only one input column, one output column, that could be simple linear regression. So the formula for this simple linear regression is nothing but y equal to mx plus c. In our school time, we would have seen this formula for straight line. If you remember our school time formulas, y equal to mx plus c. The equation of the straight line is y equal to mx plus c is the gradient and c is the m is the gradient and c is the height at which the line crosses the y-axis. So this is y-intercept. It will also be called as y-intercept. So let us see the same formula from our linear regression perspective. Linear regression also will work on the same formula. The only thing is the letters are changing. In the place of m, we will consider that as b naught. In the place of c, we will be considering that as B1. So nothing. Only the letters are changing. The working nature is same only. See the here. So beta naught is nothing but C. Let's compare this. Let's compare this equation. So y equal to mx plus c. So what it is mentioning, let us write in the reverse order. C plus mx. C plus mx. So here C is nothing but beta naught, M is nothing but beta 1. So normally in our school times, we should be calling this M as slope. If you remember, everyone, this M is slope and this C is intercept. The same terminology we will be using here also. Beta naught is nothing but intercept and beta 1 is the slope of the regression line, which tells whether the line is increasing or decreasing. And here X is input column, Y is output column. That is your target feature. Your target feature. So let me frame this in the easy way. Let me frame this in the easy way. So whatever the formula we will be using, mx plus c. So here X is input column and Y is output column. That is target column. If you remember our school times, we will be getting straight lines like this. 3a plus 4b equal to 10. So next 5a plus 10 8b equal to 50. So if you are getting these two straight lines from our school mathematics, we will be getting questions like find a and b from the above two straight lines. This is the question we will be getting from our school questions. Let us assume the same thing. Let me form a data set like that only. See, here A is my column. A is my column. B is another column. So next, whatever the equal to 10 is, right, that is Y column. So here 3, I will be getting A value. Next 4B, I will be getting Y, I will be getting 10. So next 5A plus 8B equal to 15. So for example, this is my data set. What if I want to predict if I get data like this? So if I get A as 6 and B as 8. So what is my value is what we are going to predict. So for example, 5 is 10 and so next thing is 16, let us suppose. Here I want to predict for these two rows of data set. This is my training data and this is my test data. For this test data, I need to predict the value of Y for these two rows. To identify this, pardon?
20,
Yeah.
30.
Yeah, first one is 20. Second one is 30, right? This is very simple calculation. That's why you are able to tell this is 20, this is 30. Why? Because here it is doubling and here it is doubling. But what you need to do, you need to multiply each and every number with which number you need to do?
This too.
Exactly. Into 2 you need to do. So to identify which one you need to multiply, 6 you need to multiply with 2 or 8 you need to multiply with 2
Oh, no. 3
to
multiplied.
get this 20. 6 should
10
be multiplied with 2, 8 should be multiplied with 1, right?
Yes.
In this scenario, sorry, this one, 3, 4
4, 10.
is 10 and 6 plus 8 is 20. So to which number we need to identify, we will be solving this formula. To solve this problem, we need to use some mathematics. What you need to do? We need to multiply. We need to equal this 4b and 8b. So what we need to do? We need to multiply
Just
with 2. Exactly. So below 1 should be multiplied with fifth one. That is 6a plus 8b equal to 20. So next 5a plus 8b equal to 15. So now 8b, what I am doing? I am doing minus here. Whenever I am subtracting these two, so 6a minus
A
5a,
is equals to 5.
a equal to
5.
5. Exactly. So next b equal to how much I will get if I substitute this a value in this first formula, that is 3a plus 4b. 3 into 5, 15 plus
By 4.
4b equal to 10, right?
Yes.
So what I will get? 4b equal to 10 minus 15.
By minus 5 by 4.
So minus 5. So here b is minus 5 divided by 4. So how much we will be getting? Minus
1.2.
1.25. Exactly. So what I need to do, whenever I am getting new incoming data, I need to multiply this 6 with what I need to multiply? What is the a value here? 5 I need to multiply, and this 8 I need to multiply with minus 1.25. So these a and these b values will be called as coefficients. That is, whatever the beta 1, beta 2, beta 3, all those things, right? These will be called as coefficients. This is the simple example with two equations. What if you have thousands of rows like this? In the real time, you will be getting lakhs of rows. Out of those lakhs of rows, you should get the best coefficients for your input columns. Out of these input columns, you will be getting another formula called intercept also. That is what it is mentioning, beta naught. Okay, so the entire formula we are going to develop is derived from this y equal to mx plus c only. So here c is nothing but beta naught, m is nothing but beta 1. In my y equal to mx plus c, I do have only one input column. So if I have multiple columns, my formula will be like this. So c, anyway, intercept will be only 1. If I have multiple input columns, m1x1 plus m2x2 plus m3x3, so on, like this. So some guys will write the same formula like beta naught, beta 1x1 plus beta 2x2, beta 3x3, like that. Some guys will write the same formula like weight 0 plus weight 1x1 plus weight 2x2 plus weight 3x3, like this. So normally this weight, this w will be called as weight. In the deep learning, we will be calling these coefficients as weights. Okay, so here it is coefficients or weights, anything is fine. This is about the regression. So as usual, we are predicting the continuous values here. If you are having 10 columns, you will be getting 10 coefficients and one intercept. The same scenario, if you are getting 15 columns, you will be getting 15 coefficients and 15 intercept. That is how it is explained. Yeah. So this is the simple example which we are going to consider with simple linear regression. When it comes to the simple linear regression, I already told you only one input column, one output column. So when x is 1, y also 1. When x is 2, y also 2. So like this, I want to predict when x is 7, the y value could be 7. When x is 5, x is 40, y could be 40. When I frame this data set into y equal to mx plus c format, I will be getting m value as 1, c value as 0. So whenever I want to predict for 50, I will be getting 50 as my prediction. Let us apply little bit complication to the same simple linear regression. So when x is 0, y is 1. When x is 1, y is 2. X is 2, y is 3. To get this, what we need to do? We should be multiply with 0 and we should add 1 for each and every element here. That is what we did here. Y 1 equal to whatever the y we have taken as y 1 equal to m into 0 plus c. Our focus is like I need to find out the m and c. This m and should be best. This m and c should be the best line I should get. If I get the best line, I will get the best predictions. So this is my regression line. With my data set, by taking x and y as, I will be getting this regression line. Anyway, this is the perfect data. This is linear related data we will be calling. Why? Because whenever x is increasing, y also increasing. If x is decreasing, y also decreasing. There is a linear relationship between x and y. That's why I was able to get the data like this. But in the real time, you won't get data like this. You won't get data like this. Let me show you one example in the real time scenario. So this is multiple linear regression. So in the multiple linear regression, you will be getting multiple input columns and one output column. So here you need to find out the best coefficients like m1, m2, c or b1, b2 and beta naught, whatever it is. So it's like a game of finding the best coefficients from the data sets itself. Okay, so this is how the regression algorithm will work with the formula of y equal to mx plus c. So if anyone asks you during the interview, can you explain me about the linear regression? See, linear regression will work on the formula of y equal to mx plus c. So if I apply it on the from real time perspective, so y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 like that. So here my goal is like to get the best coefficients from the data itself. That is what we will be predicting. Okay, so here we have seen simple linear regression, we have seen multiple linear regression. So let us see some simple data set on simple linear regression and let us see how this algorithm will work. Let us see how the algorithm will give coefficient values to us. So here I have taken a advertising data set for one of the company. So if the company is spending this much amount on TV, this much amount on radio, these are the publicity amount, this much amount on the newspaper, $22.1 generating for the company. If they are spending this much, they are getting sales like this. See here, whenever they are decreasing their spending, their sales also decreasing. In the first example, they spent around $230,000 on TV and $37,000 on radio, and they got newspaper on 69.2 thousand, and they got in millions. Let us suppose the sales in the millions. They got 22. Whenever they decrease this amount of spending on marketing, this is TV ads, radio ads, newspaper ads. Whenever they reduce, the sales also reducing. See here, the sales also reducing. Whenever they are increasing, the sales are increasing like this. So like this, here my client came with the requirement. So to improve my sales, what is the optimum number of amount I should spend on TV, radio, and newspaper. So if we pass in the amount on this TV, radio, and newspaper, the model should predict I may get this much sales. For example, this is my data set. Out of this data set, I need to tell my model. So if I spend 100 on TV, 100 on radio, 100 on newspaper, my model should predict how much sales I will get. So this is all. So what in the simple linear regression, I should take only one input column. I should not take all these columns. If I take all these input columns, it is multiple linear regression. So here I want to take only one input column, one output column. That is what I have taken in the below step. What I did, I dropped all the columns. I have taken only one input column. So that is TV is my X, that is input data. Sales is my output data, that is Y. So what I am doing, in the sklearn library, we do have one module called train test split. By taking the train test split, we are splitting my data into test data 0.2 means I am taking test size as 20%. If I am having 200 rows, I will get 40 rows as my test data. So here random state 40 means you can give any number. So if you can give any 50, 60, something, it's like that. Why? Because if I execute this line of code, whenever I'm executing again this line of code, the same data should be splitted. Whenever we are using this train test split, it will split the data. It will split the data in the format of in random nature. It will split. It won't split ascending order. It will split randomly. 160 rows randomly will go to X. 40 rows will go randomly to Y. So here I didn't read the file, so that's why it is getting error. If you execute the code, you will get the output. So next, I'm just checking the shape X train. See, in the X train, I got 160 rows. In the X test, how many I got? Maybe 40 you should get, just try. You will get, it will be divided into 80%, 20%. So next, what I am doing, linear regression algorithm I am importing. Like this, sklearn.linear model, import linear regression. Like this, you will be getting all the algorithms you need to read. So whatever the mathematical we did in this formula, right? So entire mathematical thing, already the developers did it, and we are simply using that library to do the model building. So what I need to do, I need to pass this linear regression to one of the variable. You can take any variable and you need to fit it. Whenever you are fitting, this fit is nothing but model training. Whenever you are using dot fit, that is model training is happening. So what you need to do, you need to provide input data and you need to provide the output data. So once if you execute it, this means it will take some time. If the data set is less, it may take within few seconds or minutes. If the data set is huge, it will take minutes, hours, and in some scenarios, it will take days also. In that scenarios, we will be running model training on the servers. Why? Because in the servers, we will be getting a RAM of 128 GB, 64 GB, 256 GB, like that, right? It will run faster. So in the SLR variable, we will be getting intercept. See the intercept. Y equal to mx plus c, right? We will be getting this c value here. In the coefficient, see, this is m value, that is beta 1 value, 0.048. Whatever we have calculated from by using those two equations, right? The same thing you got it from this linear regression. Whenever you are trying to predict for new data set, let us suppose I have taken 100, 100, 100. So in my case, let us take input data as a reference. So whenever TV is 230.1, whenever I am spending, here I have taken 2 TV only, right? Yes. Yeah. Whenever we are spending $230 on TV, whenever I am spending $230 on TV, I will be getting sales of $22. 22, let's suppose 1000. So here my testing data is, if I spend 100 on my TV ads, how much I will get sales, whether my sales will increase or decrease. So that will be calculated 1000 into what is the coefficient value, 0.0485. This thing less what is the intercept, 6.97. So what is the output you will be getting? 100 into 0.04, that means 4, plus it could be approximately 7, let us suppose, or you can take 6.97 on it. So how much I will be getting? 10.97. Like this, if you spend 500, your sales will increase. You got it right? So this 10.97, how we predicted means, we use this formula, we use these coefficients, and we use this intercept. So here, as a data scientist, our goal should be to get the best accuracy. So whatever that means, we need to get the best intercept and we need to get the best coefficient values. That means if I am testing on the tested data, it should not give the high error. That is what we are doing here. So what I am doing here, I am doing prediction on my test data. I already told you we need to take test data separately to test whether my model is performing well or not. Why? Because in the test data already some values are there. Those are real values. I need to test. What I did to test it, I need to use the dot predict function. To train dot fit methodology I have used. To predict what I have taken X test. I already separated right, X train and X test. That X test I have taken, and whatever the predictions I got it, I saved in one variable called YFET simple linear regression. SLR means simple linear regression. Next, what I am doing, whatever the actual values, that is Y values, and this predicted values, these are from my model. This YPred SLR, right? These are my model predictions. See the difference here. Whenever the actual value is 11.7, my model predicted this as 6.52. Somewhat better, little bit, some 5-6 difference, but fine. But in this case, my model is able to predict correctly. In this case, nearby at least. Why? Because we can't predict everything correctly. Only some of the things we can predict, at least. So here 12, it is 21, but very far. It is 26, here it is 20. This is also very far. Whatever the difference between actual and predicted, that will be called as error. That will be called as error. So next, what you can do to calculate the error, you can do the difference of these two columns. SLR, what you can do, difference of error equal to, you can write later. So what is this? Actual value. This is predicted value. You will be getting the difference here. Another column, error column. So regression line is nothing but this is the regression line. This line will be called as regression line. So whatever these data points are, all of our training data. So wherever these data points are there, so whenever the value is 280, it will be taking this thing and it will be taking this thing from this side, on x-axis side, on y-axis side. So this difference is nothing but error. This difference is nothing but error. So next, what we are trying to calculate, whatever the metrics we do have, right? So mean absolute error, mean square error, root mean square error, R square, all those things we will be calculating. So for mean absolute error, we will be taking y-test and the y-test predictions, and mean square error, y-test and the predictions. Root mean square means root of. So let us see the formula for each and everything. It's just like a formula only. You just need to remember, nothing more than that. So actual value minus predicted value. So mean absolute means actual minus predicted, and it will calculate the absolute value. So mean square error means see, this is the formula for mean absolute error. So y is nothing but actual output y hat. This will be called as hat, y hat, predicted output. So normally the model predictions we will be representing as y hat. You need to remember this. So what is the formula for mean absolute error? Sigma of y minus y hat divided by n. N means total number of data points. That means if you have 100 rows of data, the n value is 100. So here y is nothing but your actual value, y hat is nothing but your predicted value. That is what I have given in this example of calculator. Yes. See, this is salary in thousands is my actual values. And this salary in 1000 predicted y hat is my model predicted. Whatever the difference, right? 45 minus 42 is minus 3 is the error. So when it comes to the absolute error, 3. And when it comes to the square, it is 9. So in the mean absolute error, we will be summing all that error divided by total number of records. So in my case, total number of records are 10. So 210 divided by 10 is 21 is my error rate. That means apart from 21, 21 plus or minus, we will be getting in our predictions. Same formula with in the MAE, we will be taking absolute values. This lines will be called as absolute. If you are getting negative also, that will be converted into positive. That is the meaning of absolute. Next, mean square. Same. We are calculating square. Y minus y hat square. So root mean square, same. Whatever the MSE value, we will be taking root. Nothing more than that. Same. Square root of MSE. To read the images, we will be using this Matplotlib library. Within this Matplotlib, we do have some module called MPING. So it will be useful to read the images. Either it could be PNG or something else. So this is also another thing. Root mean square log error. The same thing. In the formula, we will be using log. Nothing more than that. And next, R square. So R square is also having the formula of 1 minus sum of squares of regression line. So SSR. SSR is nothing but squared sum error of regression line, and SSM is nothing but squared sum error of mean line. So it will take this formula and it will calculate the R square. So if you are getting R square as 67%, that means your model is performing with 67% accuracy. That means 67% of the times, out of if you test 100 times, 67% of the times my model is working fine. Remaining 33 times, my model is not able to perform. That is 33% error rate is there. Adjusted R square is nothing but the same formula which we will be using. But in this adjusted R square, we will be adding extra number of features also. In this sum of squares of regression and sum of squares of mean, you won't get features, number of features, how much we are taking. But in this adjusted R square, we will be taking those columns also. So here K is nothing but number of columns, so number of features. And N is nothing but number of data points. I will send this regression formula clearly and I will upload it. So these are all the performance metrics we need to check whenever we are building a regression algorithm. See, R square I check, mean absolute error is fine. 2.27, that is good. and mean square error, anyway, you will get the square value. That is fine. Root mean square error 2.9. That is also good. So R square, when it comes to the R square, it is 61%. That is not good. 61%. So here my goal should be like I should improve this R square into 90%, 85%, 55%, like that. The same scenario whenever you apply multiple linear regression also. When it comes to the multiple linear regression, you will be taking multiple input columns, nothing more than that. The same data set, but here the input columns got changed. So apart from one input column, we have taken multiple input columns. So TV, radio, newspaper, all of them are my input columns. Sales is my one output columns. See, I'm just checking the correlation on multiple features. So 0.78 is negligible. So 0.9, if I get, that is the thing I need to consider. There is no correlation in the data set. I have taken these three as my input columns and this sales as my output columns. As usual, splitted my data set into training and test. In this example, I have taken 30% as my test data set. 0.3 means 30%. 0.1 means 90%. Normally, industry will take 80 to 20%, like 80% training and 20% testing. If you have less data, you can take 90% as training and 10% as testing. It's up to the data scientist. If you have more data, you can take 50% as training, you can take 50% as testing. What I'm doing, importing linear regression, saving it to one variable and fitting with X train and Y train, and next intercept. I'm getting the intercept values and I'm getting the coefficient values. See, intercept is 1 only, but the coefficients are 3. Why? Because my input columns are 3. That's why I'm getting coefficients as 3. So by taking this coefficient value as reference, we can tell which feature is most important, which feature is adding more weightage in predicting the sales value. If you see all these feature values, radio is having higher impact. The coefficient value of radio is 0.18. That means this feature is most important. That is first priority for radio important. Second priority for TV. And third priority for newspaper. For this company, if he is improving on the radio marketing, he will be getting good sales. That means he need to focus on the radio. That is what we need to tell. And TV also making sense. But newspaper, very less. Newspaper is not giving any advantage. Same testing, predicting on the test data by using this predict function. And same actual value, predicted value, calculating all the metrics. See the R square. Whenever I have used only one input column, at that time my R square value is 60 only. But my R square is increased to 90%. That is the benefit of using more data. Here I have used more 3 columns. That's why my model is able to perform well. In some scenarios, if you take more columns, at that time your model may not perform well. So you should take correct columns, you should take correct algorithm, then you will get good accuracy. See, here absolute error also reduced. Before we got around 2 point, so now we got only 1. So this is how you can use the simple linear regression, multiple linear regression, and next another thing is polynomial regression. Polynomial regression is nothing but simply whatever the regression line we are getting here, right? Straight line. That straight line will be converted into the curve format. Nothing more than that. Polynomial. So in the polynomial, we will be getting a freedom, degree of freedom, one parameter we will be using. So this is the regression line. Whenever we have used the linear regression line, this is the line which we will get either for simple linear regression or multiple linear regression. But if I use polynomial regression, I need to use the parameter called polynomial. Sorry, at the same time, degree of freedom. What I'm doing, polynomial regression degree equal to 2. Within this degree equal to 2, if I do take degree equal to 2, my regression line got converted into curve format. This will be called as polynomial regression. If you use regular regression line, see the RMSE value, 15.98, and R square is 0.63. Next, Here it got reduced. RMSE reduced and R square value is increased. Let us change the degree into 3. Whenever I changed the degree into 3, see, again my R square got increased. RMSE decreased. That means it is simply tuning to each and every data point. But in the regression line, it will go only straight line. But in the polynomial, it will take like this. So for this, you need to create some polynomial features out of this X data. So it will just create some polynomial features. For that, what we need to do, we need to use this sklearn pre-processing input polynomial features. But in the real time, we won't use this polynomial regressions, all those things. Just for some may try. See here the degree is completely changed. Just for knowing purpose, just for theoretical purpose, we should learn all these concepts. See, when I use degree equal to 20, my R square value increased, RMSE value decreased completely. It's like the regression line will go to each and every data point. Sometimes this polynomial regression may not work well for real-time datasets also. So this is the concepts related to simple linear regression, multiple linear regression, polynomial regression, and next, whatever the tuning we have done from this polynomial regression, right? In the same way, we can do the tuning by using this ridge and lasso. So let us discuss this ridge and lasso during our next session. Let's confine to these 4 things: simple linear regression, multiple linear regression, and polynomial regression. I'm expecting each and everyone should go through the theory and should go through the code also. So as of now, if you have any doubts, you can shoot your questions. We will discuss this regularization concepts later. It's just like tuning our regression concepts, nothing more than that. Clear, everyone? Or you can go through the code, you can execute that and you can come up. So as compared to linear regression, some other algorithms will work effectively in the real-time scenarios. So this is the first algorithm which was developed in the machine learning. So on this linear regression, if you are planning to apply linear regression algorithms, it will have some assumptions. We should know those assumptions also, linear regression assumptions and the linear regression, this regularization techniques we will discuss during next session. Clear, everyone? Okay, then you can go through the recording session. If you have any doubts, you can go through the code. Everything is already uploaded. So I will upload this recording session in some time.